Okay, let's continue with the discussion of calculus along the for the vector variable function. Last time, I think we asked this question. All right, how do we compute the derivative of the path along the path RT that is giving you this form? And we did finish the calculation, and we got this R prime of t. This is a pure mathematical question, and you answered it with a calculation you know of, and that's it. But then maybe we can twist this question a little bit. Note. If you ask, what is the velocity vector along the path? R of t equals t squared t cubed t minus sine t. And how do we answer this question? Well, the answer will be, we should know velocity vector. Yes, R prime of t. So this is actually the twist we're adding. And if we know the velocity vector is indeed the R prime of t, yes, then we already know because we just compute it, right? So this is the answer. And the similar thing will happen if we ask, what is the tangent vector along the path R of t is t squared t cubed t minus sine t? Well, you got to provide the same answer. All right, so those are the questions without with a little bit of twist, but the actual concept and actual calculation you should go through is about the same, except that you have to just provide this extra piece of information to connect those. All right, so now let's look at a different curve, and we'll add a slightly different thing. So for a new path, R of t, which is given by yes. Okay, and we didn't really specify the t, so I will just assume this t is going to take whatever real value you could have. So the first part I want to find the unit tangent vector. And in the second part, write down the equation of the tangent line and a specific t value. So how do we answer this? Well, for the first part, we know what a tangent vector it is, right? Nope. Is our prime t. And furthermore, and the unit tangent is we denoted it by t, the t vector, which is the tangent vector divided by the length of tangent vector. So we need the two quantities, our prime t and the length of our prime t to answer the first part of the question. So let's just compute. What is our prime of t? That is relatively easy to compute, but I will not skip any step so that you know what we are actually computing in each of those steps. Okay, so this is the symbolic formula that we should follow. And let's make it small. Okay, so what is the derivative of the first term? I think it's a derivative 3 times cosine t, right? So it's 3 times negative sine t. The second term, I think, is derivative 3 times sine t, which is 3 times cosine t. And then the last piece is relatively simple. Derivative 5 with respect to t is 0. Derivative 4t with respect to t is 4. So we got the r prime of t. But to answer the first part, we need to find the length of this, which is a negative 3 sine t squared plus 3 cosine t squared plus 4 squared. So this is a 9 sine squared t plus 9 cosine squared t plus 4 squared, which is 16. So 9 sine squared plus 9 cosine squared, this is 9. So this is 9 plus 16, which is square root of 25. So the tangent vector, the length of tangent vector is square root of 25, which is 5. With those two, then the unit tangent, this is unit tangent vector, t, is this one, which is negative 3 sine t, 3 cosine t, 4 divided by 5, which has negative 3 over 5 sine t, 3 over 5 cosine t, and 4 over 5. We can check the length of this unit tangent vector. Okay. What is the length of this unit tangent vector? Now, this is negative 3 over 5 times sine t squared plus 3 over 5 cosine t squared plus 4 over 5 squared, which is 9 over 25 sine squared plus 9 over 25 cosine squared plus 16 over 25, which is 9 over 25 because those two add up together to become 9 over 25. Obviously, this is equal to 25 over 25, which is 1. Okay, so we answered the first part of the question, but the second part is something that we got to think about a little bit. Remember, in our discussion before, we have this the equation for the tangent line, right? So the key is to find this vector and this vector at a specific t naught. And so 3 pieces of information, right? The t naught value and r and r prime at this t naught. Okay, so given this question, we know the t is pi over 2, so we just need to provide r at this t naught and r prime of t naught, which we computed here, right? So we essentially have everything. Recall the equation of tangent line. Let's use the parameter s. So this is r of t naught plus s times r prime of t naught, and here we know t naught is given in the question pi over 2, and that's it, right? So we just need to provide what is this r of t naught. Okay, so where is r? R is here. Be patient. Okay, we just plug in t equals pi over 2 to it. So we got 3 plus 3 times cosine pi over 2. And I think we got then 2 plus, 2 plus 3 times sine pi over 2. And then I think is 5 plus 4t. Yeah, 5 plus 4t. 4 times pi over 2. So this is r at t naught, which has, what is cosine pi over 2? I think it is 0, right? And what is the sine pi over 2? I think it's a 1. So this is 2 plus 3 is 5. So this is a 4 pi over 2, which is 2 pi. So 5 plus 2 pi. So that's not so bad. And then we have to compute r prime of pi over 2 for this piece, which has -3 sine of pi over 2. Okay, and 3 times cosine pi over 2, and then 4. So this is sine pi over 2 is 1. So this is -3. Cosine pi over 2 is 0. This is what we have. So we have this information, and this information. We should be able to provide the answer. So the line equation, tangent line equation, and the parameter t naught is pi over 2 is 3, 5, 5 plus 2 pi plus parameter s times -3, 0, 4. Okay, so this is the end of the discussion for the example.